Okay, this is the ideal gas equation lab where we're going to find the pressure, volume, number of moles, and temperature of a gas, and then use that to solve for the gas constant. Once we have the gas constant, we can use it in other applications using the equation PV is equal to nRT. So we need to measure the other four gas variables: pressure, volume, number of moles, and temperature. To do this lab, we're going to start with a small piece of magnesium ribbon. This piece of magnesium has a mass of 0.035 grams. So 0.035 grams of magnesium is what we're going to start with. And we're going to react the magnesium with hydrochloric acid. Hydrochloric acid and magnesium will produce hydrogen gas, and we will collect the hydrogen gas that's produced. We're going to collect the gas in this gas collection burette. So what we're going to do is add 20 milliliters of hydrochloric acid. So we'll put hydrochloric acid, 20 milliliters, into our gas collection burette. And then we'll fill the rest of the way with water. Hydrochloric acid has a higher density than water, so it's going to remain at the bottom of this burette, and the water will, for the most part, sit on top of it. It won't mix very much. And we're going to fill it with water all the way to the very top. So we have water to the very top of the burette, and we have hydrochloric acid down in this section. We'll let that sit right here for a minute. We're going to take our magnesium metal, and the magnesium metal will react with the hydrochloric acid down here in order to make hydrogen gas. I'm going to tie the magnesium ribbon up to a piece of copper wire. Copper wire will not react with hydrochloric acid, so we're just using the copper wire to hold the magnesium in place. So we'll place this into the top of the burette. Right now it's just in the water, so it's not going to react with the water. And we'll just kind of wrap this around and tie it off so it stays about where we want it. Okay, we're now going to, so we have the magnesium ribbon up here at the top. It's in the water right now. The hydrochloric acid is down here in the bottom of the tube. If we flip it over, then the hydrochloric acid will start to mix with the water. So the hydrochloric acid is up here right now. It has a higher density. It's going to start moving down and start mixing with the water and eventually get in contact with the magnesium ribbon at the bottom. And when it gets in contact with that magnesium ribbon at the bottom, it's going to start producing hydrogen gas. All right, here's a look at our magnesium metal. It's been reacting with hydrochloric acid for a few minutes now. You can see the copper wire is holding the magnesium ribbon in place. The hydrochloric acid has moved down the burette and is in contact with the magnesium. And as it reacts with the magnesium, it produces hydrogen gas. That hydrogen gas then travels up the burette. So you can see these gas bubbles going up the burette. And the gas is being trapped up here at the top of the burette, and we'll be able to measure the volume of gas that's produced. So far, just over 10 milliliters of gas has been produced. And as we watch more gas bubbles move up, we see that the volume of gas keeps increasing. All right, you can see that our reaction has gone to completion. Our magnesium ribbon is completely gone. The copper wire that was holding the magnesium is still there, but now the magnesium has all reacted with hydrochloric acid and turned to hydrogen gas. And remember, the hydrogen bubbles were going up the burette and being collected. And you can see all this at the top is hydrogen gas. And we can look right here and see that we've produced 31.6 milliliters of gas. 31.6 milliliters of gas. We know that the air pressure in our room today is 751 millimeters of mercury. And we know that our temperature in the room today is 22 degrees Celsius. And we can use that information to calculate the gas constant.